Hello, my name is Marquez and I'll be talking about homogeneous nucleation. And so to start off, we'll go over heterogeneous nucleation, which is where the nucleation site is usually at an interface or a surface, and nucleation itself is the first step in the formation of either a thermodynamic phase or new structure via self-organization or self-assembly. So a common example is just with good old ice, or when water freezes, usually around some kind of impurity in it, usually some dust particle. From where I'm from, up north, a good example would be snow, where high up in the atmosphere there's a little bit of water vapor and some just floating around, and when it's super cold, it'll start to form ice around some dust particle very slowly and to make these nice structures. And then the left is a little graphic of water condensating, which here you can see if you were to drop a water droplet on a surface where this angle of contact between the surface and here is 180 degrees, which you can see here. This is about how it would form. And then here's this slight equation for those interested on the relation between heterogeneous and the homogeneous free energy required for this process to occur. And here we have two graphs relate to the energy requirements, which on the left you can see the energy requirement for heterogeneous nucleation is quite a bit lower just schematically from homogeneous nucleation, which is why you don't see this one very often. And then that's on the left. And then on the right, which we won't get into later, but just for those of you that are curious, there's a relation between this free energy, the Wellen free energy, and the interfacial free energy. So the reason why I'm interested in homogeneous nucleation is due to ice fog. So for me, I grew up in Alaska, and the part that I grew up in, it gets pretty cold in the winters. And so with pure water vapor in the air, like assuming the air doesn't have any sort of dust particles floating around, the ice fog can occur below -20 Celsius. And which in my experience for us, it usually happens around -35, -40, which some other factors kind of go into it too, such as the smog from the cars and the wood stoves and other things. But generally, the ice fog is due to homogeneous nucleation, not heterogeneous nucleation. So here we have a quick example of heterogeneous nucleation with super cold water, where this water is around -15 or -10 Fahrenheit. And so, as you will see in a bit, while it does look like a liquid now, you might not think it's that cold. When it gets poked, it forms a nucleation site around the little knife and just freezes over. And this was a nice video taken and provided by Wikipedia. And then for a fun home experiment I also found online, you can have a bottle of super cold water, right? And you can also do this with a hydro flask, but with the hydro flask you can, because it's not transparent, you have to quickly open the top to see the water freeze. But here what happens is as water gets colder, it'll start to expand just a tad with its most volume, with being the most expanded, while a liquid being around 4 degrees Fahrenheit. And so that helps increase the pressure on what little air there is here by condensing or by pushing against it. But at the same time, the little amount of air left up here in the bottle condenses. And so that ends up having a slightly lower pressure against the water, which is what helps keep it a liquid. And so if you do it right, you can either have it freeze right away as you take off the cap, or you can poke it or shake it to make it form some sort of nucleation site, or have enough of a jolt that the ice lattice structure starts to form. So quick summary, heterogeneous nucleation takes less energy than less of a free energy difference to occur compared to homogeneous nucleation. And with homogeneous nucleation, uh, the water vapor can lead to ice fog in very cold climates such as Fairbanks, Alaska, or Yellowknife, Canada, and then also parts of Russia. And a perfect home experiment, as you can see with the water bottle or with some sort of thermos, is just to have just to fill up with water. For my example, I'll use the thermos, but not so much that it's completely topped off, just so you have a bit amount of air on the top. Seal it really tight, leave it in the fridge overnight, or the freezer overnight, and then the next day open it up and look inside, and if you give it a little shake, you can see the water just freeze. Thank you.